Hello, Pre-Calc 11. We're going to be looking at rational equations today. Here we go. Rational equations. Page 348, numbers 1 to 4, 6, and 27. So, what is a rational equation? Well, it is an equation that has a rational expression in it. So, here is an example of a rational equation. It's an equation, and the variables are kind of mixed within fraction form, hence it's a rational equation. And we'll see what comes out of the woodwork. How do you solve these? Well, there's a number of methods of solving these. The one way that I personally prefer when it comes to a rational equation is I do this. So I follow these steps. I factor first. So right away, doesn't factor, doesn't factor, doesn't factor, doesn't factor, doesn't factor, and I would put this over a 1 so it looks like a fraction. So I would do factoring first. Now you could argue I could make that a 2 times 2, and there's nothing wrong with that. I could, so it just chose not to. Next thing, when you do this, is after you factored it, I would state the restrictions, much like we've done before. So in this case, what are bad values of x? Well, look on the denominator. No x there, so nothing to worry about. Bad x here, 0, because remember, you're not allowed to have 0 denominators. Do that next. Third step, what I do is I build the LCD. Even if it's no adding or subtracting in there whatsoever, I still build an LCD when it comes to rational equations. So in this case, my lowest common denominator must have a 4 in it to cover this, must have an x in it, and it must have a 1 in it, but the 4 is already going to be covering that in a big way. So 4x covers this, this, and this. So you then take this LCD, and this is, I'll just show you what happens here. I'm going to rewrite that. You take that LCD, it comes along, and it literally multiplies every single numerator. Multiply, multiply, multiply. And what you've really done is you've really multiplied this side by your LCD, and you've multiplied this side by an LCD, and because it's a minus sign there, it's distributed out. So watch what happens. I personally, if you have a different color, it actually pops out. Hopefully this red is coming out in the, so I rewrite this. I'm just going to rewrite this again just for you, just for the example purposes. And you literally pop up times 4x, times 4x, times 4x right there. Now what I do next, I don't even bother cleaning this up, because here's why we've done this. Is this denominator and part of your LCD, they divide out in that little world. So goodbye to the 4's, cancels out. Here, the x's divide out. Here, nothing divides out. So what am I left with when the dust settles? Here's the beauty of this. Remember, these are all left with 1's. You're left with x squared over 1 minus 28 over 1 equals 12x over 1. And you'll notice every single time you do this, they'll always be over 1 because you've built an LCD that has the power to destroy every denominator that existed. And because you've got the equation as a teeter-totter, you've got the balance to be able to do that. So here's what you're left with. You're left with x squared minus 2x equals 12x. Once you've done this little LCD building it and multiplying move, then you're going to solve the new equation. And in this case, what type of equation has come out to play? It's a quadratic. How do I solve a quadratic? You always get everything equal to 0. I'm going to move the 12x over, put it in the middle because I always want to have x squared x number. And now solve this by factoring, if it does in fact factor. What multiplies to give negative 28 and adds to give negative 12? Well, 28 could be 4's and 7's. That doesn't give me 12. Excuse me, 28 could be 14's and 2's. Could it not? 14 and 2, and that, if that's a minus and that's a plus, just check. X squared, 2x minus 14x is minus 12x minus 28. There's the winner. And out drops 2 answers of 14 and negative 2. The only last thing that I do is just do a quick cross-reference with the restrictions. So let me go back and look at back here. Does that conflict with this statement? And it doesn't. I don't have a 0 answer, so there's my 2 answers. X equals 14 and x equals -2. There's my answers. So there's the steps we're going to follow, which are basically, so factor, state restrictions, build your LCD, multiply both sides by the LCD. Beautiful destroying of numerators and denominators will occur. You'll be left with the denominator that is always 1 because you've purposely built something that's going to destroy everything. And then you have a new equation to solve. All right? So here's our next example here. Now as we're doing this, I'm going to put these steps up here again. Let's keep these here. Give me a sec here. There we go. So those are our steps. Okay, it's kind of a sad thing in a way, and I didn't even have this ready to go. But let me just get this on here. What I think about when I'm doing this, it's weird. It's not because of all the weird Corona stuff going on that I'm going a little bit mental. It's really, I've thought about this for years. I'm just going to Google this. I think of Star Wars. I'm going to get up the Star Wars Imperial March here. I'm going to play it in the background. It's going to be good. Okay, here we go. Here's how I think of Star Wars. So, the main thing here is... Oh, let's see, is there an ad on here?
Your business idea needs a website? So go to Wix.com. What are you waiting for? Today's the day.
Okay, that was an
Unlike
ad.
some other yogurt.
Oh, another ad.
Sikis.
This is exciting.
Simple ingredients, not a lot of sugar.
Okay, so I think of Star Wars. I'll tone it down a little bit. So as I'm doing this, it's like a battle is going to ensue. So you factor first. So this factors as a difference of squares. 10 I'm going to leave alone. 6 I can factor out a 6 into an x plus 2. On the other side, nothing factors. Except, I'm going to leave that in brackets. So I've factored it. Now I build my LCD. And I think of that as like a little Star Wars ship. My LCD has to have an x minus 2. Has to have an x plus 2. Has to have a 6. I've already got the x plus 2 taken care of, and I've already got the x minus 2 taken care of. So just take a look at my LCD. 6, x minus 2, x plus 2. Does that have the power to cover each of those individually? Yeah, with a 6 left over. Yeah, with an x minus 2. Yeah, with a lot left over. But it has the power to cover everything. And it's not too big. So this comes along and multiplies every numerator. So here's what you end up with. And you hear the music, it's getting exciting. So I'm going to put a 6, x minus 2, x plus 2 there. So it's a lot of rewriting. I'm going to put a 6, an x minus 2, and x plus 2 there. I'm going to put a 6, there's a 1 there, and a 6, x minus 2, x plus 2. Over that. And now comes the battle. Like, this is where the music is huge, okay? So you've got all the numerators having your LCD. I guess I should, before the battle ensues, what are the restrictions? 2, -2, -2, 2. So plus or minus 2. And now the destroying happens. This ship destroys the bottom ship. And you can do little laser sounds if you want, like choo-choo, choo-choo, choo-choo. And it destroys it. Over here, this 6 gone. Choo-choo. This x minus x plus 2. Poo-poo, poo-poo, gone. This x minus 2. Poo-poo. And sounds like I'm going nuts, but that's okay. It's fun. So what am I left with here? Everything is a 1 except for 2 times 6. I'm left with a 12. Beautiful. Here I'm left with a 10 and an x minus 2. Here I'm left with a 6 and an x plus 2. So after the battle, I'm left with this equation. And that is just going to, when I distribute this out, I end up with this equation, which is a new equation. and the song's just ended, but now the battle is over. This is a linear equation. I'm going to get everything onto one side. I'm going to move all the x's. It's actually a linear equation. I'm going to all the x's over here and all the non-x's over here. So as I move the 12 over, the 12s would cancel. As I subtract 6x and 6x, I'd be left with 4x minus 20 equals 0. And I can move the 20 back over, and I can divide by 4. So my answer is 5. And I would just do a quick cross-reference. Does it change? Does it influence that answer? Am I allowed to have 5? Yes. And there's my answer. So that's how I solve rational equations. Let's do one last one. Okay. See, now I want the music on. I should play it again. I gotta play it again. It's just too good. Okay, where are we? It's gonna be an ad again, probably. No, here we go. Okay, ready? Okay. So, equation, rational, factor away. Doesn't factor. Doesn't factor. Doesn't factor. Doesn't factor using brackets. Trinomial. K and K. 24 to get negative 4. It's going to be a 6 and a 4. No. Does that even factor? 24. 8 and 3. Nope. 6 and 4. No, that guy doesn't factor. That's a sneaky little bugger. Okay. So I don't factor it. So I keep brackets around it. Looks like it should factor, but it doesn't. They're trying to play games with me. The bottom is definitely a difference of squares. Man, I'm messing up here. I'm excited. That's a difference of squares. K plus 2, K minus 2. Alright. What are my bad values of x? Negative 2 and 2 again. Okay. I'm going to rewrite this because I'm not happy with how ugly that looks. So give me a second here. Okay, building my LCD. My lowest common denominator has to have an x plus 2, or k plus 2, a k minus 2, and those are already covered. So this comes along. I'm going to put a k plus 2 here and a k minus 2. Multiply both sides. K plus 2, k minus 2, k plus 2, k minus 2. And now the battle. This side, choo-choo, choo-choo, choo-choo. Goodbye to those. So what am I left with there? Just a k squared minus 4k plus 24. Not great, but not bad. Over here, k minus 2's cancel. Woo-hoo! Left with this mess. That and that with a minus sign out front. Here, k plus 2's cancel. Choo-choo! 4k minus 1 and a k minus 1. And now I have to solve this mess. It's not horrible, it's not great either. So I can look at it, at least I have no more denominators. And now I can distribute this out. So 4k squared minus 4k minus k plus 1. Here, I can distribute this mess out. K squared plus 2k plus k plus 2. Take off, change the sign on all those. So I end up with 4k squared minus 4k minus k plus 1 minus k squared minus 2k minus k minus 2. And what comes out to play? So on this side I end up with 3k squared minus 4k and minus 5k, 6, 7 minus 8k. And then the numbers I'm left with is a minus 1 on the other side of k squared minus 4k plus 24. Get everything equal to 0. I'm going to subtract k squared over here, so I get 2k squared. I'm going to add 4k, which will give me minus 4k. And then I'm going to subtract 24, which will give me 25. Now, let's hope this factors. If not, I use the quadratic formula with my ABC. Does this please factor? Because factoring just makes my life simpler. And what do we end up with? Does this have any hope of factoring? If I make that a 5 and a 5, I think it does. 2k squared, 10k, and 5k. No, the little bugger didn't work. Okay. That was my only hope. 25 and 2, would that have done anything? I don't think so. If I made that or 25 and 1, no. Okay, so I'm now worried about this question. I made this question up a little while ago. Let me just see what's going on here. Where did I steal this turkey from? Let's see. Did I write it down right? Yes, I did. What is going on here? Oh, you know what it is? I can't read my own writing. This was a k minus 2 here, which made this a k minus 2. Which then upon doing that, this is 4k squared. This is a minus 8k. And a plus 2. And then upon doing that, this was minus 8. This turned into a minus 9, 10, 11, minus 12k. And then this guy here was a 2. And 2 minus 2 is 0. I almost want to start over on this one. I might have to. I'm not happy with that. And then upon cleaning this up, we get 2k squared. Subtracting that over to the other side, you get minus 8k. And then subtracting that over, you get minus 24. I can factor out a 2 now. And then this guy does now, in fact, factor. Now, before, if I hadn't caught that error, I would have had to use the quadratic formula, and that's the best I would have done. I wouldn't have caught my little goofy error, because this factors into 2 and 6, negative, positive. Out comes 6. Out comes 2. And then I should go back and just double check, does that conflict with one of my restrictions? And I've got negative 2 and 2 are restrictions. So back here, my restrictions were this. This answer here has to go bye-bye because it conflicts with my restriction. And the only answer is k equals 6. Okay, so be careful with goofiness. Things happen where you make little mistakes there. I was excited. The music got me excited, I guess. Wrote down the 2 as a 1, or it looked like a 1 anyway. And then when I distributed that, that's all it was. I had a different collection of terms. I knew what I was doing, obviously, but I made a little boo-boo, and that happens to the best of us in the heat of the moment. So, recapping the steps, and again, factor, restrictions, build the LCD, multiply all your numerators, destroy your denominators, solve the new equation, quadratic or linear, and then cross-reference it with your restrictions. And then that is it. All right, over and out.